All right, so we'll go ahead and get started. So good morning, everyone, and thanks for joining us for today's webinar. I'm your host, Brian Pope, and joining me today are speakers Manuel Tejeda and Vinod Rodriguez from Cortex Customer Success Team. For those of you who aren't familiar with us, Cortex AI provides an open and modular AI platform for the operations and manufacturing space with industry-specific AI applications to accelerate time to value for your Industry 4.0 initiatives. Today's webinar is from the perspective of many customers implementing digital initiatives with their manufacturing data. So digitizing your data, digital batch systems, advanced analytics, machine learning. And our speakers will highlight the value and use of batch context, especially for manufacturing analytics. We'll look at how to create that batch context regardless of your current state and maturity of your data and batch systems, and how this batch context then enables advanced analytics from investigations to real-time monitoring to machine learning-based predictive and prescriptive analytics. We'll wrap things up with a question and answer session. So feel free to post any questions in the chat during the webinar, or you can post them at the end during the Q&A session itself. Thank you again for your participation. And without further ado, I'll turn it over to Vinod.
Thank you, Brian. Good morning, good afternoon, everyone. And thank you for joining us today in this webinar. So we'd like to start our conversation about batch context to really identify first, why is batch context important? What we've learned from our experiences at Cortex AI, working with many manufacturing customers, it really is that batch context really helps to empower analytical use cases. From our experience, what we've done basically is summarize and categorize the types of use cases we've seen into these 4 buckets: investigations, online monitoring, predictive monitoring, and prescriptive optimization. This is typically what we tend to do with customers of different manufacturing scales. And what we'd like to do is show how batch context is useful in these types of analytics, and then go into defining how we can build that batch context. So for investigations, we look at the types of tasks that revolve around ad hoc investigations, audit investigations, quality deviations, or even issues with specific objectives and KPIs like cycle time and yield. Preparation for this is usually extracting data from many different systems, and it's usually in a manual type workflow. What we've learned from our experiences is that easy access to these environments, to these data systems, is extremely important. For online monitoring, what we're essentially doing here is comparing our ideal processes or our current processes against an ideal reference batch or a reference process. Maybe even addressing deviations in real time and identifying when processes take too long or when phases are longer and shorter than they need to be. So what we learned here is that the context of operation, that procedural context of my process, is very critical and important. For predictive monitoring and optimization, we look at essentially more complex types of analytics. For example, batch trajectory. This requires past knowledge of my process and my batches, and even current operation knowledge. Deviation causes may require an understanding of the types of failure that the processes can experience, or even what the CPPs and CQAs are and how they influence each other. So from here, an integrated context of different data formats is extremely important, sharing that procedural context and product understanding. And as we move into process optimization, this all comes together, where not just integration, but physical, procedural context, making decisions or even corrections of your process in real time, and then even sending this information back down to your controllers to enact real-time corrections. Now, obviously, this is not all the use cases, and sometimes many teams prepare batch context as a precursor to ML and AI. But batch context for the unprepared and uninitiated is also a simple way to manage and access data. Essentially, all these use cases need data in a timely and organized and contextualized manner. So if we look at saying that meaningful analytics of batch processes is for performance investigations, for monitoring, for optimization, requires that rich batch context of data, what do we actually see in the industry right now? What does our current landscape look like? We have a combination of very different scenarios and combinations of scenarios and combinations of infrastructures. We could look at systems and environments where a BES system is being used, or is not being used, and the data for context is available, but the context is not being built. We also have situations where a BES or an MES type system is started or in the process of being implemented, but it's incomplete. And some of the context may reside in inaccessible formats, whether it's physical formats like a lab book or a logbook, or just separated databases. And in some really complex cases, of the process, the batch genealogy might be very complicated. This could be because of multiple parent and child batches, parent leading to multiple child batches, or even parallel processing. So one of the questions we ask our customers is, can you easily implement the analytics or any form of the analytics we described in the previous slide? Now, many of us do say yes. Many of us say, yes, we can implement this, and that is fair. But this yes also includes some sort of extraction of data into separate files, some sort of manual workflow. Depending on our maturity, our digital maturity, and our data maturity, we have to end up connecting these files together, maybe even using a visualization tool, and essentially sending this data back and forth. Sometimes what we don't consider is the time that we take to do this. And that ranges from days, weeks, to sometimes even months, depending on the severity of the data we need to collect. Secondly, if we have a complicated process or if we have a complicated infrastructure, all of this becomes even more tasking and tiresome. And the reason we have this is just because our infrastructure has not been designed to support these kinds of initiatives. We are making a lot of Industry 4.0 initiatives to be able to digitize our data and to not have our data in segregated formats or segregated data stores. We also have different data formats. We have different types of data formats being stored in different locations, and we don't have a standardized way across our different manufacturing environments. So our focus today is to look at how we build this real-time batch context and how we can accelerate current efforts by preparing data for analysis to make more complex analytical techniques fairly accessible. Let's agree on these challenges. We have essentially the access and organization of data. We know for a fact that sometimes it is inaccessible, our data is inaccessible or hard to access without technical help. We may have process experts interacting with data with tools like SAS, Jump, JMP, Minitab, maybe even Microsoft Excel. But data gets from the equipment or data stores or historians to these tools through a very clunky pipeline. Sometimes even IT needs to be involved. IT requests are required to be able to access data from different processes, maybe even a different manufacturing environment. And if you're a CMO or CDMO, this becomes a lot more complicated. The organization of data is also a challenge. We essentially need to look at different formats of data like discrete, time series, maybe even image, maybe even spectral formats as well. Our legacy systems are not good at organizing this. Now, to be competitive in a modern environment, you may even want to capture 3D data, video data as well. Well, how do you support these systems? How do you support the storage and access of this data with your current systems? Another challenge is data analysis. We look at the tools that we're currently using for analysis. Again, tools like JMP, Minitab, Excel, or if we are a little bit more complex, maybe a tool like Python or R. These tools need to essentially be supported with more accessible data pipelines. Trying to shoehorn modern analytical techniques into this legacy infrastructure was not going to work out for us. It's just going to leave more clunky pipelines. So we essentially want to accomplish all of this while limiting ourselves to very few tools. And we're making sure that we want these tools are future-proofed for scale, and of course, adhere to data security and governance policies. If we're working in a GXP environment, we need to make sure data integrity and accuracy is of utmost importance. So we usually want to have a solution that adheres to IT data policies and fall under the umbrella of any GXP or FDA CFR policies as well. So the solution and workflows that we're going to demonstrate now are streamlined and built to address these challenges out of the box. What we're going to do is essentially look at our customers. Now, we have labeled our most commonly encountered situations under these three personas: the SQL Squirrel, the Legacy Llama, and the Now What Narwhal. These are instances that we've seen prevalently over the past few years in the pharmaceutical, the food and beverage, specialty chemicals, metals and mining, and even oil and gas as well. Now, we're not saying that one is better than the other. This is just a situation that we have to work with. So today we're going to focus on one example from each of these personas. We'll present the problem, the current capability and limitations of this customer, and what Cortic is doing to address this batch context issue. So let's start with the SQL Squirrel. The SQL Squirrel is a specialty chemical manufacturer. They have about 5,000 employees, and they have local IT teams. So most of these local data teams or analysis teams fend for themselves. There is no national or global IT policy between the different sites, and they have no use for something like ML or AI. They're very content with their current level of analytics. Their sites are fairly standardized. They have some sort of SQL type database for data storage, which means they also have a similar maturity of data. So let's look at what they have and what they don't have. They may have, in different sites, they may have a simple historian, and in some places they have IoT databases as well. All of these organized by something like a timestamp. In their processing sites, they have manual entries from something like a logbook or a batch process record. In their downstream sites, they have sample results that are captured by either an ID or a timestamp. Again, different formats organized differently. All of this organized in a SQL table, and whenever they're capable, it's organized in a fairly nice fashion. The issue is that they only have few users trained at each site to be able to access this data. So data is limited by technical users. They need to be able to have this data retrieved by technical users and then shared with the rest of the site. They also have a limitation on essentially sharing this data and exposing this data to BI tools, just because they don't have the resources to be able to support something like this. So not all their users are able to connect to that data. Not all their users are able to streamline that data, and they don't have any context built into that data for any purposes of analysis, for reporting, or visualizations. It's simple databases storing data. So the challenge is, how could their operation and their product teams access their data quickly and create their reports and visualize data very quickly? In some cases, they depended on individuals from other sites to help out when their technical users were away or even on vacation as well. So how could we remove this dependency and have any user on the site essentially available to access that data the way they need it and analyze it or create the reports the way they need it? So let's look at the requirements of these challenge and what Cortic did.
Great. So to achieve their objective, the SQL Skirl, our specialty chemical manufacturer, needed hardware and software infrastructure. The four criteria for the solution are shown on screen. First, a robust data pipeline that united the siloed SQL databases shown on the left into the unified and contextualized database in the middle was required. As mentioned, end users didn't want to keep requesting prepared data from data owners, as manual queries could be automated. Second, this data pipeline needed to feed a solution with off-the-shelf self-service capabilities, as shown on the right. Users no longer wanted to build their own reports and struggle with migrating that data into those Power BI solutions. Third, the solution had to be easy to access and browser-based to avoid extra load on existing infrastructure. And finally, it had to be scalable. The computing resources in the cloud needed elastic scale capability. As the SQL Skirl, they're starting out, they did not know what a full rollout would look like, but they wanted to be able to bring on more sites in the future. And the rollout process, it needed to support a shared responsibility. So no more having the automation team owning all of the data systems. IT can be responsible for data connections, process experts can manage contextualization, product owners can manage that visualization and reports. So now we'll look at how the Cortic platform shown in the center met these requirements and was implemented for this customer. So let's look at how Cortic was leveraged for this SQL Skirl. Starting with the data pipeline shown on the left. From an IT perspective, the data connections are in line with the ISA 95 standard, which is very important. Two other important points about this pipeline are, first, the existence of the off-the-shelf SQL connectors were used to automate the queries to their discrete sample database and other time series databases. Users no longer had to request help from those technical users to gather that data. This was being automated up into this solution. Second, there was support for physical context. So the process expert created templates for their different equipment types. On the screen, you see tanks, pumps, heat exchangers. Afterwards, those tags that they're used to seeing in a data source centered manner, they were assigned to those equipment templates. So now when they're interested in analyzing a particular equipment, they have all the data for it in one place. You see the analysis with off-the-shelf tools on the right side. In addition to quickly having all necessary data available and contextualized by equipment, users can overlay event frames and analyze by different phases of operation. Finally, this can be extended to Power BI and Grafana easily without having to make a manual transition from that data source into this other software as they were previously doing. Now, quickly touching on the timeline, this took approximately 3 weeks, all the way from platform installation to users performing the analysis that you see on screen.
Next up, we had the legacy llama. So this is a little bit of a larger company, and this customer is a global pharmaceutical CDMO. So they were responsible for essentially designing and manufacturing generics and APIs and had about 10,000 employees at multiple different sites. This customer had a global IT team, but it was outsourced. So again, most local teams fend for themselves as the communication between the global IT, the outsourced team, and the local teams was quite disconnected. This customer was starting to use more complex analytics and needed to access a lot of data without having a reliance on data engineers or that global IT team or even local IT teams as well. And unfortunately, acquisitions of sites over the years for this customer led to no standard data management practice because of a variety of legacy systems. So this customer is essentially looking at information like information stored in a historian, context information stored in a SCADA or DCS or a batch system. And of course, they also had different kinds of quality databases like Labware LIMS. So looking at their haves and have-nots were very similar, but they started to look at more analytical capabilities. They needed to be able to access data in all these different infrastructures as easily as site 1 as they could in site 2 or 3. They did have front-end access to this data. They did have front-end access to the UIs, to the HMIs, and through whatever historian front-end screens they had, but not everything that they needed for their analysis. And because of the distinction between these sites and the acquisition of different sites over the years, it was hard for them to determine a policy that would work for all sites. It was hard for them to build an analytical policy or an analytical workflow that would work for site 1 and be confidently deployed for site 2 because of different vendor systems or just a different infrastructure as well. As they started to build and look for contextualized data for analysis, they realized that they could not quickly pull all the information required. So trying to standardize the analytics again also meant a lot of time. For some sites, it was hours to be able to perform an analytical report. For some sites, it became days, even weeks. This company did have a few resources to grow, but the resources were primarily focused on their business side and operation sides, not their IT and infrastructure side. So like the SQL Squirrel, this customer did have data in many different sinks. In addition to trying to unify it and make it available for trending, they wanted to be able to make this data easily accessible for their analytics. And they wanted to have a similar pipeline and a same workflow so that the analytics performed at site 1 could be very easily accessed or improved upon at sites 2, 3, 4, and even site N. So let's look at what the Cortex solution with this was.
Perfect. So for this customer, this legacy llama, we went through the same sequence of steps as was done for the SQL Squirrel. Different connectors were used because the legacy llama has a LIMS database, a historian, and a SCADA system, not just SQL databases as with the SQL Squirrel. Now, after successfully streaming and layering their data with asset context, the legacy llama was ready to layer product context. The two methods that you see on screen are different approaches that were taken based on the infrastructure at the particular legacy llama site. So the infrastructure varied from site to site due to acquisitions, as was mentioned. Now on the left, you see the workflow for those sites with storage of batch context, such as start and stop times. We created a recipe, and those times were directly referenced as the start and stop times of different steps of the operation. On the right, we have the case where no batch context is being tracked, and all the site had was time series data. We built a machine learning model on historical data that is labeled with the correct batch step. This model output was then consumed into the recipe definition as the start and stop of different steps, as we saw on the left side. Now, by deploying those recipes, the legacy llama could then contextualize incoming time series data with batch information. So on the left, you see a list of batches captured and detailed breakdown of start and stop times for all steps for a particular batch. The legacy llama would now have this for those sites with no historical start and stop information, as well as those sites with historical start and stop time. Like we did with asset context for the SQL Squirrel, this batch context is exposed to self-service batch analytics in the platform on the right side. Users quickly overlay batches and different phases for comparison, all pulling all that data from one place. So in addition to this, the Llama's analytical applications could pull data by asset, by batch, or by phase, and users could compare any of these things against each other, all from one data source and context location. Finally, Power BI dashboards could be connected to the single source for data and analytics.
So now let's look at the now what narwhal. So this is one of our more mature customers. They are a global pharmaceutical manufacturer, and they've essentially followed and defined a digital strategy by creating a data lake, which is no small feat. For all of their sites, they have made initiatives to be able to take the data from their on-premises data stores and push it to either an Azure or an AWS data lake. The issue is they're stuck at that now what intersection of endless possibilities. A lot of this work had been set up for storing data, but not necessarily for analyzing data. So now the customer is looking at all the efforts they've made into digitization and looking at integrating more modern equipment like MES and BES systems, but realizing that that information stored in the data lake is still flat and uncontextualized. So what do they do? Well, they want to be able to integrate this with analytical applications. Their different maturities of sites have built in either shadow IT type work of MATLAB applications or Python applications, and they essentially want to be able to connect those applications to that lake. The issue being they're stuck at the same level of essentially having to query that lake or pull that lake with flat data, and then have to organize all that data offline or on their premises and then send it to the applications. They do have a lot of resources and room to grow, but they're realizing that because they did this with the point of storing and building a digital infrastructure and not analysis, they have to redo some of their efforts in building in their context. So now they're sitting there going, now what? Now what can we do with a lot of this information? Now what can we do with analytics? And essentially, what is our path forward?
So let's see how Quartic helped the now what narwhal, our global pharmaceutical manufacturer. First, we followed the steps that we went through with the SQL Squirrel and the legacy llama. This included connecting to their data systems, in this case, that data lake, the MES, the LIMS system, and creating physical and procedural context. With this, the now what narwhal had access to the previously explored self-service capability, those that we saw with the SQL Squirrel and the legacy llama. But this wasn't enough, as this company had data teams and a readiness for advanced analytics use cases. So on the screen, we have the capabilities that they were able to access immediately as a result of the previous connection and contextualization efforts. On the left, you have historical batch investigation. You might be familiar with MVDA. So they're now able to use batch context to compare batches and identify the influential time series process parameters. No migration of data from collection point or historian to analytics application was required. In the center of the screen, we have online batch evolution monitoring. You might know this as golden batch modeling. Drawing from the MES information, they were now able to understand the live batches and monitor for deviations from the ideal phase trajectory of those batches. Now, this workflow took just a few clicks more than the MVDA analysis on the left. And finally, on the right, you have optimal closed loop control. This algorithm is built for small data sets. Think a manufacturing process that may only run 10 batches per year. With the ability to overlay context, the time of sampling and PAT measurements can be aligned with other process data, and the optimizer can look at historical control and objective parameter measurements to recommend ideal set point changes for live batches. The now what's, they now have direction as to how to use their digitized data and expand their analytical suite. So we've spent time talking about how this solution was deployed to meet the requirements of customers at different digital maturities. We looked at these steps to implement once, but we didn't talk about what the expansion looks like throughout the enterprise. That's just as important because a solution that does not scale well will not have meaningful impact. We touched on those shadow IT teams, data teams working in MATLAB, Python to build solutions at their local sites, but they don't scale well. So let's look at what this scaling looked like at these customer sites with this solution. Summarizing the Site 1 deployment that was done for each customer type, the first step was to deploy and install the environment, this Cortex platform, in Site 1 and establish streaming data connections. Afterwards, SMEs created asset and product templates. Using those templates, they instantiated their assets and products. In the case of the SQL Squirrel, they only went as far as the asset context. They weren't quite ready for that product and batch capability. Then, for whatever stage in the digital journey the site was at, be it a SQL Squirrel, Legacy Llama, or the Narwhal, they then jumped to their respective analytic stage. Now, Site 2 and onwards became easier. The environment didn't have to be deployed as the existing one scales to accommodate new sites. The first step at these sites was for SMEs to directly leverage existing asset and product templates, so those templates that were created at the first site, and they only had to create new ones as required. They could programmatically use APIs to instantiate hundreds of assets and products simultaneously. As with Site 1, the users proceeded to whatever stage of analytics their particular site was at. So in the case of the SQL Squirrel, there was consistency across the enterprise. All the sites were at a similar stage. The two other customers, they had sites jumping to different steps of the analytical journey due to their differing maturities. This was okay because Lighthouse sites explored applying these solutions to different use cases across their processes. Because of the asset and product templating across sites, deploying these solutions at other sites became easier.
So these aren't the only personas available. As we mentioned earlier, there are many different personas or even combinations of these personas in the manufacturing sphere. We have also different data focuses and data formats being collected in the manufacturing environments. The adoption of IoT sensors and the streaming and collection of that data is a very prevalent task happening in manufacturing environments. In some cases, even process analytical technology using spectral data to analyze your process in real time needs to be not only streamed and collected, but also analyzed and decisions made in real time as well. And the adoption of images and video as well. So whether these are high definition images or thermal images for processing, all of these images and video need to follow the same kind of pipeline as discrete, IoT, or process analytical technology. That data pipeline and storage and contextualization is shared and needs to be shared for analytical purposes. The kinds of analytical purposes can also range, whether we're looking at something like closed loop control, where again, I'm pulling information from my shop floor, sending it to the cloud, making a decision on that, and then sending that suggested set point back to the controller or the historian to be processed. These are just some of the experiences we've seen over the past 2 years. We've seen a lot of focus on reliability as well, asset performance monitoring. This includes being able to contextualize the asset, but also going into deeper ways of contextualizing how the asset could fail. So adopting failure modes. In a similar manner, we could do the same thing to adopt the quality target product profile of your process or product and capture that context as well. The idea is that we essentially want to be able to build the context in any environment for any analytical purpose. So at this point, we're going to wrap up our presentation and just open up the floor to any questions from our audience.
Great. Thanks, Vinod. Yeah, so we have had a couple questions come in during this, but if you have any others, please feel free to submit them through the chat window. So we had one question to kick this off. You mentioned several times about connecting to data sources. So how does that connection work? Is it a custom script, a one-time export? And does it require some sort of custom connectivity? And how does that work?
Right. So what we've essentially done is we've pre-built a lot of manufacturing connectors and manufacturing protocols within the Cortex environment. So there's no customization required for these connections to data systems. What essentially has to happen is a configuration. The connector is ready to go. You configure it with the connection settings, so the server settings, the tag, and the information that you're pulling, whether it's a historian, a control system, or even a data lake. There are different types of protocols. So OPC, MQTT, even Modbus to directly speak to a PLC. This information is all pipelined and pulled into a central store, and that the context is then developed and built on top of that central store.
I'll just add, sorry, Brian, I was just going to add a little bit to that one. So I think in addition that those connectors, they're installed on a lightweight edge VM. So if you noticed on some of the slides, the SQL Squirrel, the Legacy Llama, the Now What Narwhal, we tried to list out the type of resources that were required for this application, the implementation of these solutions. So that edge that's collecting the data in particular, that can go on something as light as a personal laptop.
Great. Thanks, Manuel. And there was another question similar to data connectivity that I'll just jump to. So someone asked, I have a lot of this context already built in a system like Pi. Can that be leveraged? And then, just put your own analytics products on top of that existing data store.
Yes, absolutely. So if you have context built in a separate custom environment or a system like OSI Soft's ASA framework, yes, our OSI Pi connector can directly connect to that system, bring a lot of that physical context on top of into the Cortex environment, and then give you the opportunity to build in that procedural context. So understanding where these physical assets are used under which product, and then what the operation of those procedural operations of the product look like. You can break it down into a unit procedure, operation, phases, and even go down into phase steps as well. All that work can be leveraged from a system like Pi or even your custom framework environments as well.
Great. Let's see. And then in terms of analytics tools, so changing away from the data connectivity a little bit, how do these batch analytics tools compare to other ones such as Jump that you mentioned, and my organization also uses MATLAB?
Yeah, you want me to take this one, Manuel?
Yeah, kick it off a note and I can add if there's anything else, I think.
Okay. Yeah, so it really depends on the kinds of workflow, the workflow and the workflow and the initiative of the analysis. We are not, the Cortex system and applications doesn't provide a workbench to support these analytical tools. We're following under workflows and specific initiatives. So for example, a few of the things we showed were reliability and multivariate analysis. What you may be able to do in a system like JMP and MATLAB is explore your data a little bit. And of course, go into details about building something like an SPC report or even modeling your data in MATLAB. What Cortex allows you to do is do the same thing of exploration, but also take that model that you've built in MATLAB or any other environment and also deploy it online seamlessly as well. It's all integrated into one environment. So the same data that you extract information and context from to build a model or analyze your batch trajectory space or your design space, that same context can be, with a flick of a switch, deployed online so that all that intelligence that you've built offline is now connected for streaming data as well. I would invite you to look at the capabilities a little bit more deeply and compare and contrast them. But at the very start, that's one of the biggest differences that at least we have with Cortex.
Did you want to add anything, Manuel, or are we good on that question?
I think Vinod covered most of it.
Okay, great. And then one final question we have here, if anyone has any others, now's your chance to enter them, but has this been deployed in a GMP environment?
We are currently working with our first GXP deployment. We're undergoing validation in our first GXP deployment, and our global pharmaceutical customer is also looking at deploying this across their sites in a GXP environment as well. So we're currently under our first validation process, and that first validation is actually one of the more premium ones where we're not just deploying for data collection, we're actually being deployed for data collection, analysis, and real-time control of their systems as well. So Cortex is being used to essentially identify what product is being created, what are the operations and the quality product profile of that product, and then go as far as to be able to recommend set point changes and optimize the product during process performance as well. This is being done for their upstream processes, and they're looking at adopting it for the downstream. That the other global manufacturing customer, the Now What, is looking at basically deploying Cortex now for all their sites as a data collection and analytical visualization tool. And yes, we do support validation with our own validation packages, and we can assist you with your GXP validation of the tool as well.
Great. That looks like it's all the questions we have today. So with that, I'd like to wrap up and thank everyone again for joining us for our webinar today, Enabling High-Performance Batch Analytics with Rich Batch Context. We hope you found it valuable. And if you would like to learn any more, please reach out to us here at Quartic AI. Thank you.